Tonight, something extraordinary happened above our heads. A faint smudge in the night sky, the interstellar traveler known as 3I Atlas, suddenly erupted in a burst of emerald light. Not slowly, not over hours, but in minutes. Amateur telescopes around the world captured it. The comet's coma flaring green while its tail rippled, as if a wave had just struck through space itself. The footage spread like wildfire through astronomy networks, and within hours, scientists were scrambling to verify what they were seeing. At Harvard, astrophysicist Avi Loeb reviewed the data and noticed something no one expected: a precise timing match between that sudden flare and a coronal mass ejection from the sun. It wasn't coincidence, it was interaction. For the first time, we may be watching our own star collide with an interstellar visitor in real time. What 3I Atlas just did could change how we understand comets, space weather, and the deep mechanics of alien worlds. At first, few believed what they were seeing. A flare that intense, that fast, simply didn't fit any comet model we know. Some thought the data must be corrupted, maybe a calibration error, a sensor glitch, a passing satellite flare. But as the minutes passed, the evidence only grew stronger. Independent observers from Austria, Namibia, Chile, and Japan all reported the same phenomenon, captured through different telescopes, under different skies, at the exact same time. For those who've followed 3I Atlas since its discovery in early July, the object has always been an oddity. Its orbit slices cleanly along the plane of the planets, unlike most interstellar bodies that approach from high inclinations. Its velocity, nearly 60 kilometers per second, is extreme even by cosmic standards, fast enough to escape the sun's gravity forever. And yet, the comet's brightness has remained strangely steady until this one sudden explosion of light. That is where the confusion begins. Most comets gradually brighten as they near the sun, venting gases and dust in predictable cycles. 3I Atlas broke that rule. It sat quiet, cold, seemingly stable, then erupted like a cosmic light switch. Scientists began asking the same question. What could make a body this massive flare so violently, so briefly, and then return to calm? Was it something internal, like pressure building under a frozen crust? Or was it something external, a strike, a shock, or even a deliberate pulse from deep space? The deeper researchers looked, the less sense the numbers made. The light curve wasn't random, it was structured. The color shift wasn't gradual, it was instantaneous. And as the discussion spread through Harvard, NASA, and amateur observatories online, one name kept resurfacing: Avi Loeb. Because Loeb's latest data set hinted that what happened to 3I Atlas might not be an accident of nature at all, but a moment of contact between worlds. By the following morning, the images were everywhere. Streaks of green light arcing across telescope sensors, the once straight tail of 3I Atlas bending in a way no one could explain. Professional astronomers joined the conversation, and soon, the world's most advanced instruments were turned toward the interstellar comet. The first data came from the European Space Agency's ExoMars Trace Gas Orbiter, which had a partial view as it orbited the red planet. Spectral readings confirmed what amateurs had already suspected. The comet's coma had erupted with a massive release of diatomic carbon, glowing bright emerald under sunlight. Normally, that color takes hours to develop. Here, it appeared in minutes. Something had injected tremendous energy into the comet's gas cloud. At Harvard's Center for Astrophysics, Avi Loeb and his research group pulled telemetry logs and solar wind data. What they found was startling. 5 days before the flare, a coronal mass ejection, a vast wave of magnetized plasma from the sun, had blasted out at millions of miles per hour. Its projected path intersected with the predicted position of 3I Atlas almost perfectly. Loeb ran the numbers twice. The timing aligned within less than 1 hour. He called it a rare cosmic coincidence, or perhaps a laboratory-scale experiment written by nature itself. But there was another detail, something even more puzzling. Despite this violent outburst, the 3I Atlas barely deviated from its expected path. Normally, when comets vent large amounts of gas, the recoil acts like a set of tiny thrusters, pushing the object slightly off course. Here, the trajectory remained almost perfectly gravitational. It was as if the comet were too massive to care. NASA's Near-Earth Object Center quietly updated the orbital solution. Zero measurable non-gravitational drift. That single line of data changed everything. If the flare was real and the mass this enormous, the implications were staggering. A comet several miles wide, dense enough to ignore jet forces, had just been hit by a solar shock and lit up from the inside out, without losing its path or coherence. No comet in recorded history had behaved this way. Astronomers debated through the night. Some claimed it was just a new vent opening on the surface, a patch of pristine ice vaporizing under sudden heat. Others argued the timing was too perfect. The CME impact and the flare matched too precisely. And then there were the skeptics, the ones who whispered about possibilities no one wanted to say out loud. What if 3I Atlas isn't fully natural? Loeb didn't dismiss the idea, but he urged caution. Extraordinary data doesn't always mean extraordinary intent, he wrote in an internal memo that later leaked. But this event forces us to re-examine how interstellar objects interact with our star, and what they might reveal in doing so. In other words, for the first time, Earth had a front-row seat to a live experiment written in plasma and light. The sun and an alien wanderer locked in a brief, explosive conversation across the void. Tonight, the world's eyes are once again fixed on that same patch of sky. Every major observatory from Mauna Kea to Paranal, from the James Webb Space Telescope to the Hubble, is scheduled to point toward 3I Atlas. The reason? This object is now crossing the orbital path of Mars, the very region where that solar shock wave was predicted to pass again, as it continues expanding outward through the solar wind. NASA's Mars Reconnaissance Orbiter, MAVEN, and ESA's Trace Gas Orbiter are in position. They could, by sheer luck, record a second interaction, a side-on view of whatever just struck this interstellar comet. If that happens, it will be the first time in history we witness a three-dimensional collision between the sun's plasma and an object born around another star. The data window is narrow, only a few hours. The comet is racing past Mars at over 130,000 miles per hour. Every minute counts. Instruments must balance exposure time, spectral filters, and telemetry compression just to catch a few usable frames before 3I Atlas disappears behind the planet's limb. Avi Loeb described it best in an interview earlier today. "This is not just a comet," he said. "This is a messenger from another system. If we can see how our sun's energy reshapes it, we're looking at a universal experiment, physics written across interstellar boundaries." But behind the scientific excitement, there's quiet tension. Within NASA's internal data channels, many engineers admit they're worried. If the outburst tonight grows stronger, if 3I Atlas flares again under a second solar strike, the energy involved could be immense. Not dangerous to Earth, but powerful enough to disrupt instruments, blind sensors, and flood deep space receivers with electromagnetic noise. And then, there's the matter of ownership. Who controls the data if a historic event unfolds? ESA, NASA, the Harvard team, or the thousands of amateurs who might capture it from their backyards? In the age of citizen science, the line between professional and public discovery has blurred completely. So, why does tonight matter? Because if a second flare occurs, it won't just confirm the solar impact theory. It will reveal the inner anatomy of an interstellar object, its chemistry, its crust, its volatility. Details that no probe, no spacecraft has ever reached. For a few hours, the universe itself has opened a window, and everyone with a telescope is standing at the edge, waiting to see what happens when sunlight meets something not made in this solar system. As the observation window narrows, scientists have begun outlining three possible outcomes, each one stranger and more revealing than the last. Scenario 1, the safe theory. In this view, the flare was simply geological, if such a word can be used for ice. Somewhere beneath the frozen crust of 3I Atlas, volatile gases like carbon dioxide or methane have been locked, away for billions of years. As the comet approached the sun, that internal pressure built until one section of the crust gave way, venting a concentrated plume into space. When the gas met sunlight, it fluoresced brilliant green, the signature of diatomic carbon. This would make the flare an accident of timing. The CME from the sun just happened to arrive at the same moment the vent cracked open, giving us the illusion of cause and effect. In short, nature got lucky, and so did we. If this scenario holds, the brightness should remain elevated for days before gradually fading as the new vent stabilizes. The coma will expand, the tail will smooth out, and 3I Atlas will resume its quiet, predictable journey past Mars. It's a beautiful story, and the least dramatic one. But tonight, no one in the control room seems ready to bet on quiet. Scenario 2. The dangerous theory. This is the version that keeps space weather specialists awake. In this case, the solar storm, not the comet, is the trigger. When that wave of magnetized plasma slammed into 3I Atlas, it would have compressed the comet's ionized gas cloud like a giant electromagnetic hammer. That compression could easily ignite short-lived chemical reactions, stripping electrons, exciting carbon molecules, and causing the coma to light up in a burst of green fire. The tail's violent kink, the ripple moving through it like a whip crack, would be the visible echo of that impact. If that's true, 3I Atlas might not be finished. The comet's trajectory takes it through several regions of disturbed solar wind over the next few days. Another strong CME could strike again. And if the first event was powerful enough to alter the coma, the next might fragment the comet entirely. That's why NASA's instruments are in emergency watch mode tonight. But then there's Scenario 3, the extreme hypothesis. This is the one few dare to say aloud, except behind closed doors and encrypted channels. It begins with one question. Why did the flare occur so abruptly, so precisely timed, and so localized? Loeb's data showed the surge lasted just under 7 minutes, a perfectly smooth rise and fall. That's not how random venting behaves. Natural outgassing fluctuates, sputters, and decays unevenly. This pulsed. Some in the theoretical physics community have begun whispering about engineered periodicity, a pattern that could suggest either mechanical rotation with perfectly balanced thrusts or some unknown resonance responding to electromagnetic input. No one is claiming alien technology, but everyone is aware that 3I Atlas is not behaving like debris. If the pattern repeats tonight, if we see another controlled rise of brightness at the same timing relative to the solar wind's arrival, it will shatter the assumption that this is just a piece of rock and ice. It would mean the comet is responding, not merely reacting. Each of these scenarios carries distinct predictions. If it's a natural vent, brightness stays high and steady. If it's a solar shock, the flare fades quickly and does not repeat. If it's something deeper, structured, rotational, or resonant, the flare will return on schedule, like a heartbeat written in light. And that's why every telescope, from professional observatories to backyard rigs, is pointed at the same coordinates tonight. The next few hours may tell us whether 3I Atlas is a silent wanderer or something far more deliberate. Even if tonight's event fades quietly, its implications will echo for decades. For the first time, humanity has watched the raw chemistry of another solar system react to our own star. Every molecule released by 3I Atlas carries the signature of its birthplace, a fingerprint of the conditions that once surrounded an alien sun. In a very literal sense, this is interstellar archaeology, layer after layer of cosmic history exposed not by shovels, but by sunlight. If the green flare truly came from buried gases, then we are now sampling pristine material that has been sealed since the comet's formation billions of years ago. That composition could tell scientists how common life-building compounds are beyond our solar system. A trace of formaldehyde, a hint of amino acid precursors, even certain carbon ratios. All of these would reshape how we estimate habitability around other stars. But the event also raises uncomfortable questions. Who owns interstellar data? When the next 3I class visitor arrives, will its readings belong to NASA, to the European Space Agency, or to the global public? After tonight, the line between professional discovery and crowdsourced science may be impossible to draw. Thousands of amateur astronomers are already sharing synchronized observations online. Some of their light curves are more detailed than institutional data sets. The democratization of discovery has never felt so real or so uncontrollable. Ethically, it's a new frontier. If 3I Atlas fragments or continues to flare, the information gathered could shape billion-dollar missions for years. Whoever holds that data holds the key to understanding how interstellar debris behaves near stars, and possibly how to intercept, or even capture one. It is easy to imagine the debates already brewing. Should such an object be studied jointly under an international framework, or will one agency try to claim it as a national asset? Avi Loeb has been outspoken on this point. "Knowledge should not be territorial," he said in a press briefing earlier this week. "The universe doesn't draw borders, neither should science." Yet even Loeb acknowledges the philosophical weight of what's unfolding. If 3I Atlas is natural, it still rewrites the physics of comet stability. If it's not, then we are standing on the threshold of something entirely new. A sign that intelligence, in some form, has left traces far beyond its home system. Either way, the long-term consequence is clear. Tonight, we are not just observing a comet. We are watching the first chapter in how humanity will handle encounters with things that don't belong to this sun. While headlines focus on flares and equations, the real heartbeat of tonight's story belongs to the people watching, the ones who haven't slept in days. In Pasadena, engineers at NASA's Jet Propulsion Laboratory sit in a dim control room, their screens filled with live telemetry from Mars orbiters. Every few minutes, someone whispers a timestamp, marking another data packet arriving from the red planet. Across the Atlantic, a small team in Darmstadt monitors the ESA ExoMars Trace Gas Orbiter, verifying exposure sequences as it swings behind Mars. Outside, the world turns quietly, unaware that these night shift scientists are about to witness something no one has ever seen before: sunlight striking a visitor from another star. In a quiet suburb of Vienna, amateur astronomer Thomas Lehmann sits beside his aging telescope, the same one that first caught the emerald flash. His computer hums, cooling fans clicking softly in the dark. A small chat window on his monitor blinks with messages from other skywatchers: Japan, Chile, Australia, South Africa. They share calibration data, images, even tiny corrections for atmospheric distortion. None of them are being paid. None of them will make headlines. But without them, the discovery wouldn't exist. On Reddit and Discord, thousands follow live updates, watching faint lines of green emerge on composite images as they upload frame by frame. Some are students, some retirees, some professional astrophotographers running rigs from backyards. Together, they have built a digital observatory larger than any single agency. At Harvard, Avi Loeb stands near a window overlooking Cambridge, phone pressed to his ear. It's near midnight, but the media requests haven't stopped. He looks tired, but his eyes are bright. When asked what he feels in this moment, he pauses for a long time before answering. "Curiosity," he says softly. "We spend our lives looking up, waiting for the universe to surprise us. Tonight, it did." That's what connects them all: the amateurs, the students, the scientists buried in data centers halfway across the world. They share the same silent awe that every observer feels when the cosmos changes in real time. It's not just science, it's participation in something vast, unpredictable, and alive. And as data streams in, some blurry, some perfect, those thousands of human eyes remain fixed on the same distant point of light, united by one impossible truth. For a few brief moments, an interstellar visitor reached out and touched the light of our sun, and we were awake to see it happen. By dawn, the data will be here: lines of numbers, faint pulses of light, compressed packets of history traveling millions of miles to reach our antennas. Somewhere in that data may lie an answer, or maybe just another question. In a world obsessed with certainty, nights like this remind us that science begins with wonder, not conclusion. We have measured the orbit of 3I Atlas, mapped its mass, and tracked its dance with solar storms. Yet, for all the precision, we still don't know what it is. Just a frozen relic from another star? A fractured piece of a lost world? Or something designed, something that crossed the gulf between suns carrying a purpose we can only guess at? The universe doesn't hand out explanations. It hands out moments, brief, luminous, unrepeatable. Tonight was one of them. When future generations look back, they may not remember the equations or the orbital data. They will remember that for a single night, humanity watched the sun and an interstellar traveler collide and realized how small and how connected we truly are. If 3I Atlas fades quietly into the dark, it will carry with it our curiosity, our instruments, our questions, fragments of our own intelligence reflected in the cold. And if it flares again, if it glows once more in defiance of expectation, we will be here to witness it, to measure, to wonder. Because that's what makes us human, the refusal to look away. Whether 3I Atlas is stone, ice, or something born of reason, it has reminded us of the one truth that outshines everything else, that the universe is still capable of surprise. So, as the last green glimmer fades beyond Mars, we wait. Not in fear, but in quiet anticipation. Tomorrow, the world will wake to headlines and debates, but tonight, beneath a cold and endless sky, we remember the cosmos is not finished speaking, and we have only just begun to listen.